Hey, so today we are going to be talking about fossils. Fossil is any naturally preserved evidence of life. So, life that used to exist, and the evidence for it is found like in nature. So there's many different examples. The most common type that you would find, though, are the bones of creatures that used to exist, or like the skeletons for it. However, as this video shows, there's actually a really interesting process that takes place, which is that over time, when you have bone that's inside of the ground, the bone eventually wears away. I mean, the same thing happens to your bones too, especially in your teeth. If you go to the dentist, if you're unlucky to have teeth that are prone to cavities like myself, you go there and there might be a little hole starting to form. The dentist will go ahead and fill in that cavity. So if you think about it, if you have a bunch of cavities with fillings inside of it, it's like your original teeth aren't 100% there, right? Your teeth are still there. It's the exact same shape as your teeth, but now there's like some kind of metal inside of it, or some material that's inside of it filling it up. And that's what happens to all of the skeletons and the bones that go inside the ground. What happens is that little cavities start to form in, and then minerals that are coming in from groundwater will then fill in those gaps. And if you do that for a long enough time, the entire skeleton gets replaced by these minerals. However, it's the exact same shape, and it still gives us plenty of evidence about what that creature was like. So, still very useful to find those things, even though that those bones have been replaced. Other important details that I want you to write down is that you only find these types of fossils inside of sedimentary rock. So, igneous and metamorphic, the way that they form, they would just destroy the fossils. Think about it. Igneous forms from magma that cooled down and then formed into rock. So first, any fossil evidence inside there would melt away when it turns into magma or lava. And metamorphic forms from intense heat and pressure. That heat and pressure would destroy the fossils as well. Now, to find fossils, there's a couple things that need to take place. One is erosion. So, erosion would carve away the surrounding rock to allow you to see the fossil. And then uplift, when you have tectonic forces that are being squeezed together, that will bring fossils that are inside the sedimentary rock deeper down to the ground. That will bring those types of rocks closer up to the surface. And then again, more erosion will wear that away. So, erosion, uplift brings it up to the surface. Erosion carves away the outside of it to bring it there. So, yes, when you go inside of the Museum of Natural History, like here, the first thing you see are these amazing representations of these dinosaurs that used to exist. But again, for the most part, it's not the original bone that was inside there. Over the 65 million years plus that they've been inside the ground and then dug up, they did eventually get replaced by minerals. This is one of my favorite representations of it because a lot of times when you see these fossils, you just, imagine what they were like. But here you see an actual interaction. They know that because there's actually bite marks inside of the head plate inside of this Triceratops over here, which is pretty cool. So this is in the Smithsonian in Washington, D.C. Now, there's other ways that fossils can take place. There used to be these tar pits. There's actually a place in Los Angeles called the La Brea Tar Pits where they found a whole bunch of bones in the same area. It was probably really confusing for the scientists to dig into those tar pits and separate all the many different types of bones that were in there. So what could have happened here is that maybe a prey animal got stuck in the tar, and then it was such an easy prey opportunity for the predator of the Smilodon or the saber-toothed tiger. It was too much to resist, so it just went in there. Here we see that this is an ancient insect that was preserved inside of the sticky substance of amber that's located inside of a tree. The entire premise of Jurassic Park was actually based around this, where they found like a mosquito in there. They go into the mosquito, they extract the DNA, and then they make all the dinosaurs from there. There's a couple of reasons why that would not work in real life, but it's still a really cool sci-fi idea that I like. So here's the imprint of some of the earliest creatures to ever exist. This is called a trilobite. So trilobite, some of the earliest creatures that we ever know to exist. If there's anything inside the fossil record older than this, we just haven't found it. So that's like one of the oldest creatures we know to exist. Could have been something older, but we don't know. So the imprint of this creature inside of rock, like these ammonites over here, is one of the ways we learn about it. There's also footprints over here. Now, you have to keep in mind that there's different things that can destroy fossils and make it a little bit more difficult. For example, if there was a fossil here, but then because of uplift or shifting of fault, it may have pushed it upwards. So you kind of have to like do some CSI, crime scene investigation, to put it back where it was and get the correct age for it. And then over here, we see that there's an intrusion over here. So there may be some fossils in these records over here that were destroyed because of the magma that came in here and destroyed it. Speaking of fossils, this is a place in Texas that I went to called Dinosaur Valley State Park. And it was really cool because you could just walk right up to them. Like, there was nothing stopping you. You know, so many places in museums is like, don't touch, don't do anything. You can go right up to it and touch it if you want. So this is pretty cool that these footprints from these giant dinosaurs were preserved over, millions and millions of years. Still there for you to go see if you want to. So please jot down this definition. This is a paleontologist. Ology is a study of something. Ologist is a scientist who specializes in it. So this is paleontology, study of fossils. And you could see that when this paleontologist is studying these fossils, they're not doing so with like these crazy tools that you can't really recognize, right? It's kind of humble materials over here. This guy basically has like a paintbrush over here. So the reason for that is these bones are really, really fragile, really easy to break. The more you break them, destroy them, you drastically decrease the value of them. So what we want to do is I want you to think about over here, what is an area that you would dig for fossils? So look at all these different locations. What are the issues with them? Over here, we see that this is Central Park in New York City. It would be very difficult to dig there because, of course, you would need permits to dig in Central Park. It would be almost no chance of you being allowed to dig there. And there's a lot of buildings that are in the way that you would not be able to uproot. I want you to take a guess right now, looking at all these different locations. So this is Central Park. This is on the ocean floor. This is the Arctic tundra. This is the Amazon rainforest, a volcanic island, a dried up river canyon, a mountain range, and then the desert. Over here, practically speaking, when you're digging for fossils, you're literally digging with a shovel and like a brush. So this would be very difficult for you to get down there, although there probably are lots of fossils that are actually down there from ancient sea creatures. If you go over here, the Arctic tundra, I wouldn't be surprised if there's some fossils there. It just makes it really difficult to dig there if you don't really have a good starting location, like a tip for where to begin, because the ground will be so hard to dig into. Speaking of difficult places to dig, the heat and the animals and the bugs would make it very difficult to dig in the Amazon rainforest, but also all these trees have lots of roots that make it really difficult to dig in with your shovel. You have a volcanic island. If it's a volcanic island, a lot of igneous rock you can expect to be there, which may destroy some of the fossils there. Now, the canyon's very interesting. You could see the strata that are there, the layers, which means that this is sedimentary rock. So not only is it sedimentary rock, but the water erosion that's taken place has already done some of the digging for us. So it might make it easier to dig there. We don't see any evidence of fossils, but this might be a better location than some of the other ones. Over here, this is not, if you see how the lines are kind of like folded upwards like this is not strata. This is actually foliated, which means it's metamorphic rock. Metamorphic rock would destroy the fossils. So not our best location. And now over here, this is probably the second best one over there, but it's not really a clear place to dig. You start to dig in the desert over there, and after a couple hours, the wind may just blow it all back. So if you don't have some sedimentary rock to carve into, it's not going to be as good as this one. So this location is going to be our best bet, the dried up river canyon right there. Now, when we construct the geologic column, we're trying to learn how things existed in the past. So you might just find section A in one location, find section B in another one, but B has part of A with it. You might find C, which has part of B with it. And then when you put them all together, you can see, oh, this is the age of everything, with the oldest being on the bottom. That's the principle of superposition, right? We've learned that the oldest is at the bottom, newest is at the top. Same thing is true for fossils. So when we look back in the geologic record, the most recent things that went extinct were right over here in the Holocene. So you can see things like saber-toothed tiger and the woolly mammoth right over there. You could see some bones of, mammal-like creatures most likely that were here, but now have gone extinct. You can actually, it's fun to talk about some of those mammals. Like this is the Glyptodon, I believe it's called, which is like a giant armadillo. which is about the size of like a Volkswagen Beetle, so about the size of a car. You could see over here you have the giant ground sloth or ground sloth. I mean, this thing was absolutely huge, 5.5 meters. That's at least 18 feet tall. That could be. So if this is a human, look at the size comparison over there. They called this the terror bird. Look how much taller this one was than a human. These are not creatures I would want to coexist with, and yet humans did coexist with all of them. They all existed at the same time that humans were around. So we have the Paraceratherium, another like relative of a sloth. You have the woolly rhinoceros, sometimes known as the Siberian unicorn. You have the Amphicyon, the giant bear dog, and another type of, I think this is just the sloth that's not standing up this time. So, I mean, a whole bunch of creatures that used to exist, but they all existed in some range in between here. This was in the Cenozoic. They're now extinct, but we find fossil evidence that they used to exist. So right around here, there was a gigantic extinction, and this kind of separated into a totally separate era over here. That included the Cretaceous, the Jurassic, and the Triassic. Can you take a guess what types of creatures roamed during this time period? Yeah, you can see the T-Rex skull. This is the time of the dinosaurs. So they went extinct about 65 million years ago over here, but they had a nice long run of, almost 200 million years. They were kind of like the top dog species over there. I like to think that that's the Glossopteris over there, which we've discussed before. And then as you go over here, before that, we get a lot of sea creatures, a lot more primitive creatures, until we get right around here, the trilobites that I discussed before. And that's around, 500 billion years ago. 500 million years ago, pardon me. And then everything before that, we don't really know for sure. Very few fossils exist around that time. So this is a time that we think that a huge explosion of life happened right around here. I believe they call it the Cambrian explosion. But it's interesting to go back in time and learn about how all of these things, existed. And we know, of course, that because these are found in a lower rock layer than these ones, that these are significantly older than those. So this is what's called relative dating, when you can compare one thing to another and which one is older. So let's do an example of that, of relative dating over here. So layer, box W, which is right over here, you're going to pick one of these two things. So either layer B or D, and layer, and then box J or L, are the same age. Ooh, the same age. Each layer contains the same type of box Y, either fossils or rocks, because they formed during different or similar time periods. Let's see if you can figure this out. Take a guess. Well, let's look at B. B looks like this, and J looks like this. Over here, D has similar coloring, but different patterns, so it's probably a different rock. But they do have the same types of fossils that existed. And yes, feathers, fossilized feathers would be fossils, evidence of life. So because they have the same type, right, this would be D and J. That's like my initials, Daniel Johnson. Look at that. They have the same type of fossils, so they probably formed during similar time periods. So that'd be the answer to that one. Another example, you can look at these and say, all right, what can we learn about each of them? So let's start with B. B, does it support the idea that land was covered by water at the time that this was, or that it was exposed to air, or we don't know enough? In this one, because there's footprints in the ground, most likely it was exposed to air. Now you understand how to do the next three? Give it a shot. Let's look at C. There's no fossils here that we find, so we don't know if it was covered by water or air. It will be this one. D. Feathers, most likely exposed to air. Although, it's possible, there are some creatures that can fly and go in the water, but at least it was exposed to air, so it probably wasn't totally covered by water. So most likely it would be that. And then the last one, E, we could see shells over there, and it looks like the outline of an ancient fish, so most likely covered by water. All right. If we look over here, we can see the rise of humans. So if you look over here, roughly 4 million years ago, roughly 12,000 years ago, roughly, there's about 4 million people on planet Earth. Now, if you fast forward, around 7,000 years or so, it went from 4 million to 27 million. And then another 4,000 or so, you get 2.5 billion people. And now we're approaching 8 billion people. So we have done an exponential amount of population growth in this time